Okay, we are live. Cool. Man. Yeah. Right, we have things to do. Many things to do. Poke around, GitHub. Let's see. One second, folks. We do this. Okay, we are set over there. Silly, somebody wanted to do a poker agent. Alright. Uh-oh. I want to work on edge param sweeps. Cool. We get back on stream, we do this. Not this. Blinding. Hyperparam stuff. I want to focus up on this a little bit. This is going to take a little bit of thought. Maybe not necessarily too much thought. So I've got this test Gaussian process thingy. This is just a throwaway script. And the only thing I really want to figure out today is what the hell's wrong with Gaussian process variance. All right, that's all I want to figure out. So, let's just do this. Score equal score.rand. Oops. And what's the frickin' torch random? Torch rand, duh. Alright. $50. Let's see. Obs. And then we do some stuff. So we have this. We got the error. We don't need this. Nope, there's no token. The one that's using my name is by somebody stealing my name. That is a scam. Okay, how obvious can you be? No, you can't just join this stream with multiple accounts at the exact same time and expect me to believe this is real. Bye-bye. Stupid. No way. Christ, man, do you have enough accounts? Holy hell, do you have nothing better to do? Leave me alone. No. Okay, we don't really need this piece, do we? Okay, very low error. Very low variance. Oh, that actually worked better. So whatever happened before was weird. Yeah, okay. I don't know why it tries to keep adding this 10. Along the lines of AlphaGo 0, I built a Monte Carlo tree search algorithm and I've been testing perf for some simple games with a heuristic function. I assume this is from the Discord messages before. Does PufferLib have a self-play transcript to train one agent while its opponent uses a fixed policy? So I think you could just pretty darn easily, like, yeah, you could very easily do that. Does it have like a module for it? No, but I think you could do it in like 10 lines of code change. So this is what you would do. Yeah, okay. My bad. I'm a bit on edge because I've been getting brigaded by like crypto nerds on my stream. I just banned 3 accounts. Um, for a second I thought you were another one, but we're good. So this is what you would do. Let me find it. Okay, so there's this thing called masks in the environment. If you pass something to masks, it doesn't get used in training. So if you set the mask 1 on a specific agent, it doesn't get used in training. So for like a 2-agent environment, if you have a bunch of copies, you would just set like every other one of these to 1 or to true or whatever. False, I think, masks it out. Yeah. So you'd set every other one of these to false to mask out half of the policies. And then all you would do is inside of clean PufferL, which is right here. Okay, all you would do is you would take the observation and you would just reshape it. You know, you would just split it every other one, or fancy index it. So you take every other one, and you'd use one policy for one and one policy for the other, right? So you take your fancy indices, actions of odd, log prob of odd, whatever value of odd equals policy 0 of O device of odd, and then actions of even, log prob of even, you know, you get the point. That would be the like few line quick way of doing it. It would still be pretty darn fast. It would work just natively with training, and it would let you use a fixed neural net policy accelerated by PufferLib. It requires you change a couple little things custom, but hey, every other library that supports this, or like can support this, has way heavier and slow stuff usually. So I think that's a pretty easy way to get it working. Actually, you know, I want to do something a little better than this. Yeah, let's do something a little better than this. Look at this. We got a speed up from 2,000 to 450,000 steps per second. So nice to see that, though. Look, just right out of the box, they mess with Puffer for a few days, and they get 200x speed up. Would you recommend creating 2 agents which train against each other, or only train one and have the rest be fixed previous iterations of itself? Ooh, if you want to start with the most basic version of historical self-play, which doesn't have sampling or anything, and maybe is enough to bootstrap off the ground, what I would probably start with, I would just have one opponent, and I would basically, whenever you get above a certain win rate against that opponent, I would replace the opponent with the current checkpoint. And then you should be able to very easily verify whether this is working, because your train curve should start off at 50% if it's random policy versus random policy, and then it goes up to, let's say, 80% win rate is your threshold, right? And then it drops immediately to 50 because you're playing against yourself, and then it goes back up to 80, so you should get this sawtooth kind of a curve. Thank you. Yeah, no worries. Anytime. Let me know how that goes as well. And if you end up making, fast M code to go with this stuff, we are very happy to have this stuff in Puffer. And I don't know your engineering background, but if you haven't seen like CMs like ours before, they're very, very easy to write. I say this as somebody who wrote Python for 10 years. We've got brand new devs writing these environments at a million steps a second. So we just want this, right? Test pred minus obs. Obs. Where's it? Test GP. Why? I don't think I posted anything. I my X and socials and stuff are very intentionally apolitical, except for stuff specifically concerned with AI. So I will comment on AI legislation and things that pertain AI, but that is it. I don't think I made any post to the contrary, did I? I don't think so. No, I made one comment to the CEO of Razer that was a game meme. That's it. Something screwy here. Yeah, I'm not gonna comment on political stuff outside of AI. That's been my policy for years. At least not on stream or, socials or anything. I'm not here to tell you about politics. I'm here to I mean, my content is purely on reinforcement learning and the science and the engineering. Does this work? This one is spot on, right? Wait, synthetic. Work on project that use RL for process automation. So yeah, I'm here for it. Yeah, that sounds awesome, right? The idea with Puffer is that we're gonna start off, right? Like most of the companies and stuff that we're gonna be working with starting off, it's gonna be applications where people have a clear-cut RL problem and are just having a hard time with it. Something where we can build a fast sim, we can easily help with stuff. RL is just hard and finicky, we make it easier. But as we build out better stuff with Puffer, harder problems across automation in various industries, especially manufacturing and the like, industrial processes, really just various industrial processes, are going to be definitely targets for RL. And god damn it, this freaking not Julia discussion again. Sick of the damn programming language discussion in the freaking Discord. ridiculous. We're here for RL. Come on. Okay, this is hyperparameter tuning hour. So I guess I should have probably explained what it is I'm doing. Well, Discord is not distracting me. Clean RL PPO. No, clean puff RL. Clean puff RL is the cleaned up one that's super fast. Handle opponents making moves. They don't. That's the thing. You set the mask to false. Every other mask you set to false, and that data will go through the forward pass, but it won't go through the backward pass. You see? Yeah, you're looking at the wrong script is why. Here. So, right. Find it. Yeah, so right here. This is stored, and it's stored using the mask, you see? And then when we store, we only store stuff where the mask is true. So if you set the mask to false every other one, it'll just be gone. And then all you have to do is use the fancy indexing in that forward pass. So you literally have like 3 lines of code to change, and you're good to go. You just have to remember to set the masks. So for folks on YouTube, because we've got 6 people watching now there, what I'm going to be trying to do for the next hour, hour and a half until I get tired, I'm just testing out some Gaussian process stuff. Because we have this really snazzy hyperparameter tuning algorithm, which I am very proud of. It gets some very good samples. It's like a very nice sampling distribution, but it's very dependent on the accuracy of the internal Gaussian processes for modeling which points to select. And right now they're very high variance and they're very overconfident. So I'm trying to figure out what's up with the Gaussian processes here just by doing some synthetic tests to evaluate where Gaussian processes are accurate, how accuracy falls off over time as you get farther away from the points in the data set, and so on. Subbed on YouTube? Fair enough. Welcome back. It was weird with this error thing, right? Test error. Yeah, for Insomniac, I do stuff like this where I think that hyperparam tuning is one of the highest leverage things in RL right now because they're so finicky. And if you can just make it so that if you run a 100 experiment sweep, you are just absolutely confident that you have good hypers and that anything that's wrong with your experiments, it's not hypers. And if it works, it'll get the best hypers. Like, it's going to make all of RL feel so much more polished and consistent. Oh, look at this. Keep getting distracted here with other RL things, but user wants assistance. I am on stream to assist. Particularly for folks that are open sourcing stuff and writing M's for Puffer. Too many variables in C step. Let's see, C reset, RNDF. Ray casts. Okay. How many rays? 8. That's not bad. 8 ray casts is fine. Step. I'm kind of surprised if this is slow. Let me say if... Where are your loops, man? There should be slow things. I wonder if they're just profiling it wrong. Let me say. Doesn't look like it. $450K with training. Well, why didn't you say so? My guy. Wait, with training. Well, what's the env? Don't you have an env profiler? You have an env profiler, right? Right here. Did you run this? This font is way too gigantic. I was gonna say, that looked like it should be faster than that. Drone. I'm gonna run this real quick as well. We compile. What? Oh. That's kind of silly. How the hell did I manage to break this? The funny thing about this is this should be literally impossible because it's not, it's everything statically linked. Dude, what the hell is this? Does this run for you? Okay, good. Because I messed around with some stuff earlier and I must have broken some things locally, and I am too tired to fix this at the moment. I want to just do my Gaussian process stuff and go to bed. 7 million FPS. Very nice. So in that case, I will fix your model or whatever real quick, and then I will sleep. Well, not sleep. I'll do this and go to sleep. What's your graphics card? Their model on this? Default? Oh, well, that's why. It's actually, that's kind of impressive that this gets 450,000 on CPU. It's only going to be training on one core of that. Maybe we should, well, the thing is you're probably running a tiny little model if it's just default policy. You could add the LSTM wrapper into this, recurrent or whatever here. It'll train slower. You need a GPU to train properly. If you need help running some sweeps, I can probably do that for you. We have 4090s with Puffer. Are you running it with multiprocessing? No. Well, that's weird because our M here, this only uses one core with native vec. So I don't know what PyTorch is doing. Maybe PyTorch CPU knows how to multi-core or whatever. I don't know. But 450K on that, yeah, that's pretty good in that case. With a small policy like this, typically we can go above 1 million on a 4090. Alright. I will answer whatever additional questions. But there you go. Your M is so fast that you don't even need to worry about multiprocessing it when you're at 7 million. When you start getting close to like 1 million or below, then that's when you start thinking about multiprocessing it. Well, at 7 million, it's just fast enough that you don't have to care about anything. Oh, reward scheme. Hold on. Penalize it for hitting a wall. I don't know what the scaling is. Closest. Yeah, I don't know what the scaling is here. I don't like this continuous reward. Yeah, I don't like this continuous reward scheme. I would just give it a flat negative 0.5 on the step that it runs into something and call it a day, like negative 0.5 or something for running into an obstacle. Scaling is from a pay. Really? Okay. I would still, as a baseline, I would see if you do better just giving it negative 0.5 on the step it collides. Because I don't know how many times this gets applied, right? This could get applied repeatedly a whole bunch. You should be able to learn to fly around pretty easily. You also, do you guys have Wannabe set up? Or Neptune or one of those? Are you getting logs from this thing yet? You should be getting logs. Because I want to see your losses. Because, like, look at your hyperparameters. Alright? You've got a batch size of 260K, a mini batch size of 4096. So, division is hard at this hour. Oh, link a Wannabe if you can. Hmm. These are cool looking. If you have Wannabe, you can link it real quick. I can just take a quick look at your losses and save you some time before I go back to my other stuff. I suspect this batch size with this mini batch size and these epochs is horribly unstable. And that's what's getting you. Also, these lambdas and gammas are insane. I don't know where you got them from. Actually, most of these hyperparameters are utterly insane. Where did you get these? Do I link? Well, if it's a public Wannabe, you just link the Wannabe like dashboard link. If it's not public, then you can either make it public or whatever. Yeah, you swept too much stuff is what happened. I can show you. I will fix this for you real quick if I have the link so I can show it to you. Or just the losses screenshot, I guess. Gotcha. I'll let you do that so I don't talk at the same time and confuse you. I'll just look at my stuff in the meanwhile for a second. Mm-hmm. Very weird. Test obs, test pred. Why is this so high? Oh, stupid. Okay. Hi, brother, new here. What's happening? A few things at the moment. I'm working on some testing for a hyperparameter sweep algorithm for reinforcement learning. This is all like reinforcement learning dev. And I'm also waiting for a user of our library to post some links to some experiments so I can do a little bit of quick analysis for them, get them on the right track. Come on. See if this is fixed. Yes, so this is now fixed. Perfect. Yeah, this is the exact graph that we would like. Oh, here we go. Fix my graph. And now I have some experiments to look at. All right. So for folks watching who are new to RL, this is probably when you'd want to tab back in, because this is likely to be very informative for you. We're going to go look at two different things. And this is going to look a little silly, but no, this is, of course, you're going to not know this. It's a newcomer. Literally everyone makes this mistake. I'm going to look real stupid if it's not this and the losses, but I'm pretty confident it will be. Yeah, so, and we need to change the axis as well. They always change, they change their UI, man, so I can't see the x-axis. There it is. Okay, so 100 million. Whatever this is was added later, I guess. Okay, we've got exploding entropy here. We have got weird policy dip, and then this actually surprisingly doesn't look too bad, but the value loss here is unstable. You can see this, and here as well. I actually wouldn't blame you for missing this, except for the entropy. The entropy one's pretty obvious. But otherwise, I wouldn't blame you for missing this here, because it's not as obvious on the graphs, but I can tell you from the hyperparameters. So you don't want to sweep all of this. If you sweep max grad norm, value function coefficient, and you didn't sweep the clip coefficient, so it's kind of interesting that it still did this. One thing that happens that's kind of weird is it'll lower the value function coefficient a lot, so that's why the value function is exploding. It's not training the value function. And it'll produce these like weird on-rails runs where you can get pretty decent performance for a while, but then the run just collapses catastrophically. So what I generally suggest for people is, unless you really have a good reason, don't tune value function coefficient, don't tune max grad norm, and don't tune any of the clip coefficients. You can tune the rest of them. You should probably also limit this mini batch size is crazy. You have a ridiculous ratio here. So whatever this divided by this is too big. This is like 50 or something, 64 probably. Yeah, this is too big. And then you multiply by update epochs, and you're doing like 100 some odd updates on stale data. Now, why would you do that? You have a really fast environment, right? You have unlimited brand new fresh data. So use your unlimited brand new fresh data. You can leave this like this if you want, so it's like very big batches. But then this is going to have to go to like 32K. And then update epochs, we'll see if this needs to be 3. I'd be surprised. It's probably going to end up at 1 or 2. Let's see what else. Lambda and gamma are just insane. These are set for like 2-step horizon problems. This is like what you would expect for a multi-armed bandit or something ridiculous. So whatever gave you this is insane. And yeah, this is what'll happen when your hyperparameters get into a wonky, unstable regime. That probably would have been more eloquent in the morning rather than at 8 p.m. After I've been doing stuff all day, but that should be sufficient quantities of RL insights to get you on the right track here. I bet this one's pretty bad in terms of the hypers, right? This is this run, yeah. 0.27 value function. That's why the value function was exploding. Also render your agents so you can actually see what they're doing. It's the other good thing you want to be doing. Okay. We'll answer whatever follow-ups on that, but that should be what you need to get on the right track here. Sweep that got us weird hypers. What did you run? What did you run this with? Because this isn't a sweep. Like a Wanby sweep. Yeah, those are some crazy hypers. It's good to learn to know the like the interpretation of the hyperparameters. We can render. We use drone.py. Very good. Yeah, so watch them. We can sweep. That one should work. Just a random search, so it's not a great sweep. The carbs demo in there should be decent as well. But the problem isn't the sweep algorithm in your case. The problem is the is sweeping too many parameters. So I don't know what's in the base sweep config on the main branch, but take out, all the redundant stuff. Really, the most important parameters, you can just even set like manually. You could set this to be 130 or 260, and then just set the mini batch size to 32K, and you'll probably find some decent parameters just sweeping learning rate, entropy, lambda, and gamma. You'll probably find some decent parameters in there. As for better hyperparameter sweeps, it's coming. We're going to have the best hyperparam sweeps in the business once I finish this. And once I figure out insane Gaussian process things. Of course, always happy to help. Back for status update tomorrow? Very good. Yeah, I'm particularly always happy to help, academic people who are like contributing, environment code and stuff. I'm very happy to help with that. Pretty much the only thing that I won't help with is when, like substantial sized companies are demanding large amounts of support help for free. That's the only time where it's like, okay, guys, you should get a priority service contract. Pretty much everyone else, it's like, yeah, we're good. Why is the error in this specific direction, I wonder? Test prediction minus test op. So it undershoots. Why don't I just put in test observation and test prediction? All right, we know it should be a line. What? Something weird here. Oops. Why did test error work before? The axis totally off. Yeah, no, this doesn't make any freaking sense that this test error is like this. X scores. Right? No, this doesn't make sense. So unless I'm being particularly stupid, okay, so this is there. Red. Test ops. Red my test ops. Okay. First of all, it should be test ops minus test Fred. Would be the way to go here. That just flips it. This doesn't make much sense. Oh, unless the axes were off. Hold on. Yep, the axes are off. You can see that the slope is wrong here, right? So in this regime, right, this is perfect. And then the predictions are totally wrong over here. Because it should continue this way, and it slants off this way. It's a very weird error pattern. That it's like this perfectly consistent predictor on the wrong line. Okay. Let's see the standard deviation. Well, if anything, this is hard, right? It says it knows that it's wrong. So already by cost 2, they've got an error of 1 factored in, right? And we can do error. Okay, so here's your variance. And here's your error. So by 2, it's got a 1 factored in. And the error is only 0.5. Error goes up to 4. I mean, we're happy with that. I mean, this is the pattern. What if we do this? The error suddenly gets better. And if we look at the predictions, are the predictions good? Oh yeah, the predictions are solid. Look at that. Now, the thing is there's a linear kernel in here, right? So we're going to have to do, let's make this a little harder, right? X equals rand 50. Y equals dot log of x. It's 1. X plus y. this work? What we're going to try to do is we're going to fit this to a log distribution, and we're going to watch the error, and we're going to see if we can figure out any issues with the error pattern of Gaussian processes, which is going to be important for this hyperparameter sweep. Getting kind of tired, so brain not fully working, but you know, we'll get there. I mean, yeah, sure, we'll get there. I'd like to at least have something to show here before I go to sleep. Okay, cool. So test prediction. Nah. We'll just do test y. Test y equal test y. And then, because Python doesn't care where you define things, p.scatter. Purple, I guess, source equals. Okay, and then we just do this. See if this does it. Doesn't like that. I just want to put them on the same graph. Come on, man. Why do all plotting libraries just, why are they all a pain? Oh, I think it's y equals test y, right? Yeah, silly me. All right, that's on me. Columns must be the same length. This is x equals test x. Add this in like this. Come on. Come on, how's this not handled yet? Error. Columns data source must be. Oh, seriously? Okay, fine. Oh, this plot's gonna be useful. Hey, there we go. What? Oh. Silly. Okay. Somehow that's perfect, right? Oh wait, no, it's perfect because Yeah, we're silly. We're just very silly. Task. Can't be perfect. That would be ridiculous. Yay, there we go. No, there's no way it's that bad, right? We should plot the true data on the bottom, I would say. So we plot this first. So can we see from here? Yeah, they overlap. Look, you see this? They overlap perfectly within the support. You see the purple mixed in? And then right around here, they break away. And they break away in like a weird catastrophic way as well. What happens if we do this? I'm hoping here this doesn't just immediately fix. Well, I'm not hoping. I expect it's not going to immediately fix. Yeah. So this makes it more linear. You see this? When you put 10 in, it just makes your prediction align. And then we can try 0.1, which means the matern kernel takes over. And you still get this fit actually with the matern kernel up to here, but then the matern kernel does this somehow. So neither of these kernels is going to save you essentially. So we may as well go with the default. That's kind of useless, isn't it? All right, let's do another experiment. 2 times rand 100. Now you have more data. Can you fit? No, you get the exact same pattern, right? Double the data. Double the data here. So why is the coloration so weird? That's weird, but whatever. So you double the data, you get the exact same error pattern. This thing will not learn no matter how much data you throw at it. That's kind of bad. Okay. What if we do... Do we have to scale all the data? Is that a thing? We don't need any of this. So for training here, x norm. And then what we do, test norm, test pred, test y. Hang on. What happens if we do this? Okay, so here's before norm. And now after norm, it makes the right shape at completely the wrong scale. It's kind of funny. I mean, does this really even make sense, right? The output variable of the Gaussian process. The output variable of a Gaussian process is never going to be like a normal distribution, ever, in the case of hyperparameter tuning. So you can like try to force it to be a normal, right? But you're going to get stuff like this. Hold on, is this even possible? It doesn't match at all. Like, it doesn't match anywhere on the distribution. Can I do this right? Let me just make absolutely sure. Now this is correct. This should be totally correct. I just changed the scale a little bit with different data. Hmm. Mm-hmm. Tempted to like go get logistic regression. It's literally just yeah, sigmoid is all it is, right? Does that even make sense either? Like, no, it doesn't, right? Yeah, this is, but it's really crap because you're depending on the output variable to be a standard normal, but it's never going to be a standard normal. So you're basically trying to come up with clever transformations to fit it to a standard normal. But the thing is, it's never going to be the like a reasonable standard normal. So you get this weird shift where it's like it has the right shape, but it doesn't match the target distribution at all. Hmm. Hmm. You don't want to fit a curve. You don't want like a classic curve fit because you got a bunch of input variables. So that'll overfit. It's like deceptively simple. Maybe it's just the kernel is stupid, you know? It's just the kernel is stupid. Hold on. an RBF kernel. Okay, the predictions go back to 0.